In this example, we're asked to plot each point to form the triangle ABC, and we're going to verify the triangle is a right triangle and then find its area. And then we're given the 3 points. A is -6, 3. B is 3, -5. And then C is -1, 5. So the first thing would be to plot these on a coordinate grid. So once we have our points, we're going to verify that it's a right triangle. So we're going to find the length of each of the sides of the triangle using our distance formula given 2 points. So the distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the difference of the x coordinate squared plus the difference of the y coordinate squared. Alright, so we're going to do that for each one of these 3 legs. So we're going to get a lot of practice finding our distance formulas. Alright, so for the distance first from A to C, so we're going to have the difference of the x coordinates, so -1 plus 6 squared, plus the difference in the y coordinates would be 5 minus 3 squared, and then I'm going to take the square root of all of that. So what do I get if I do that? So -1 plus 6 would be 5, 5 squared is 25, 5 minus 3 is 2, 2 squared is 4, and then 25 plus 4 is 29. And the square root of 29 can't simplify, so I'll just leave that distance just like that. Next we'll find the distance from C to B. So looking at those 2 ordered pairs, we're going to have the difference of the x coordinates. So -1 minus 3 squared plus the difference of the y coordinates is 5 minus -5 or 5 plus 5 squared, and take the square root of all of that. So -1 minus 3 is 4, 4 squared is 16, 5 plus 5 is 10, 10 squared is 100. So then I'm going to have the square root of 16 plus 100 is the square root of 116. And if you wanted to, you could simplify that. I'm going to be able to pull a 4 out of here, so this will simplify to 2 square root of 29. Alright, finally for this last side, AB, we're going to find the difference in the x coordinates. So then I will have -6 minus 3 squared, plus difference of the y coordinates would be 3 minus -5 or 3 plus 5 squared, and then we'll take the square root of that whole thing. So I'm going to get 9 squared, which is 81, and then 8 squared, which is 64. Go ahead and add those together and we get the square root of 145, which does not simplify. Alright, finally, after all of that work, we can answer the question that's being posed to us. Let's verify that this is a right triangle. In order for it to be a right triangle, the side lengths have to satisfy the Pythagorean Theorem. So the question is, does a squared plus b squared equal c squared? Or do the legs, when I square them, equal the hypotenuse if I square that distance? So looking at this, the hypotenuse would be AB. Right, so that's what I'm going to have to make sure I put in for this c value. So when I go to substitute this in, maybe I'll do that first so I don't forget that. The square root of 145 has to go over here for c. So then the other 2 distances go in for my leg lengths. And in this case, it might be easier just to use the unsimplified version of this. So I'm going to use the square root of 29 squared plus the square root of 116 squared. And I'm wondering, does that equal the square root of 145 squared? So the square roots and square root cancel, and so I'll be left with 29 plus 116 is equal to 145. Is that a true statement? And you will find out if you add 29 plus 116. Yep, you betcha. I get 145 is equal to 145. So this indeed is a right triangle that satisfies the Pythagorean Theorem. Alright, so we're almost done. The last thing we're asked to find is the area. So the area of a triangle is found by 1/2 times base times height, where the base and the height meet at a right angle. So on this one, the right angle would be right here. So, and it doesn't matter which one of the side lengths you call the base and which one you call the height, but it does matter that you use these two side lengths. So the AC and the CB side length has to be used. So I'm going to have 1/2 times AC is the square root of 29, and CB is the square root of 116. And in this case, it actually might make sense to use its simplified version, because if I put the 1/2 times the 2 together, those will just come out to 1. And then the square root of 29 times the square root of 29 is the square root of 29 squared, which just simplifies to 29. So then I get the area as 29 square units.